Hi there, we are going to solve some density problems in this video. So here we are. A cube of osmium metal, 1.500 centimeters on a side, has a mass of 76.31 grams at 25 degrees Celsius. What is its density in grams per centimeter cubed at this temperature? So the big thing to know is that density is equal to mass over volume. So we're searching for density, that's our question mark. We are given a mass, it says 76.31 grams. And then we would need centimeters cubed, but it actually didn't give us that. It only gave us centimeters. However, it says it is a cube. So length times width times height will give you the volume of a cube. So we have 1.500 centimeters. I'm going to use parentheses cubed because I'm cubing both the 1.500 and the centimeters label. So this means we have 76.31 grams over, don't know what 1.5 cubed is, so give me a second. 3.375 centimeters cubed. And then I just need to do that division. 31 divided by 3.375. We have 4 sig figs, so 22.61, and my labels are grams per centimeter cubed, and that is the label they asked for. So that is a final answer for A. So very straightforward. But now let's take a look at B to see what happens if you are not looking for density, you're looking for a different piece. So B says, here we are. I lost my pen, just give me a second. There we go, B. The density of titanium metal is 4.51 grams per centimeter cubed at 25 degrees Celsius. What mass of titanium displaces 65.8 milliliters of water at 25 degrees C? So water displacement is one way of measuring volume when you have an irregular shape. So in A, we were able to just multiply length with height because it was a cube. But if you don't have that, then you use water to see how much water spills out. At any rate, solving. Okay, so we know that density is equal to mass and volume, but this time we're looking for the M. We don't know what the mass is. So it is highly recommended by me that you solve the variables first and then substitute in your numbers. You will write less that way. It doesn't feel like it, but you will have fewer labels to write. So if I want mass to be equal to something, instead of density equal to something, good old algebra, if I'm undoing dividing, then I multiply both sides. So mass is equal to volume times density. And now I can just plug in the numbers they gave us. So mass equals, volume was 65.8 milliliters. And we're going to multiply that by the density, which was given as 4.51 grams per centimeter cubed. Okay, now there's a little bit of an issue on the labels here. We have milliliters for volume and centimeters cubed for volume, but I will let you in the greatest secret of all chemistry. 1 milliliter is equal to 1 cubic centimeter. So they will actually cancel out. So milliliters, milliliters, and then will be left with just grams, which makes sense because we're looking for a mass. So just do the multiplication, 65.8 times 4.51, and we have 3 sig figs. So I'm going to round this to 297 grams. Okay, again, pretty straightforward other than changing the equation around a bit. And lastly, let's do a C. Here we are. The density of benzene at 15 degrees C is 0.8787 grams per milliliter. Calculate the mass of 0.1500 milliliters of benzene at this temperature. So this is actually the same as last one. We're looking for mass again. So we already know that mass is equal to volume times density. So we just put in the numbers. So our volume is here. We have 0.1500 milliliters of the benzene, and its density is here, 0.8787 grams per milliliter. This time the labels do match officially. So milliliters cancels out. I have grams, and go to the calculator. 0.15 times 0.8787, 4 sig figs will be 0.1318 grams. There you have it. Just quick side note, if you had to solve for the volume, start with the definition of density, mass over volume. And then you would do that first step where you multiply both sides by volume. So you have mass equals volume times density. And then to get volume by itself, divide by density. So volume is equal to mass divided by density if you were asked for volume instead. All right. That is it. Have a great day.